16F74. It's got 40 pins on it. It's going to have 33 input-output lines, but they're going to be grouped in 8. Okay? And so we can sometimes do this. If we want to say that these 8 lines are going to go over here to some address A0 through A7, we could just say port D is coming over here, use one line, put a slash through it that says there's 8. That makes, I mean, otherwise things can get pretty complicated. Everybody all right with this? Okay. And if you had 6 variables, again, you would put 4 16 variable maps next to each other, and it's not too hard to see who's in common. So in this cell here, so along here is A, B, C, and D. This would be E, F equals 0, 0, E, F equals 0, 1, E, F equal 1, 0, and E, F equal 1, 1. So, no, you don't have to. Yeah, it probably would help because, yeah, I think we probably would do that. Somebody's not going to work. You know, I mean, if I made this, well, wait a minute, let's see, 1, 1, that would be okay. This one was what, 1, 0? I think we're okay. Going from here to here, one variable's changing. Here to here, one variable's changing. Here to here. I think this would work out. Yeah.
So could you stack them any which way while they're like this, or?
No. No. So if I had these 4 1s, you would say, and everybody else is 0s. What would you say this particular? How would I group those? Could I group them into 4? Okay. And so the term would be A, B, C, D, bar, 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 bar. All the terms negated. Right? Okay. What happens if I have, we'll pick a different set of 1s here. 1, 1, 0, 0. Could I put those 2 1s into a group of 2? Yes, because only one variable would be changing. Everybody understand that? Okay, what would happen if I had this and everybody else were 0s? Could I put these into a group of 2? The answer is no. I cannot get from this guy to this guy following a path where only one variable changes.
So you can only move side to side or up and down between the boxes?
You just can't go diagonal just like we've seen before in the other maps.
So these ones aren't stacked on top of each other?
You can think of them as stacked on top of one another if you wanted to. But, you know, it gets a little confusing. But you understand the thought process to put a group or a 1 into a group, you have to be able to get to it by only having one variable change. Right. Last time at the end of the hour, I started talking about the physical attributes of gates, and I'm going to hold off on that. We're going to go through some other stuff here before we come back to that. Where I was heading with that is that the original gates, these were TTL gates standing for transistor logic, and these are BJT transistors, not MOS transistors. It was better to have the output, anytime the output was high, very little current came out of the gate. Take an output low, and then a milliamp had to come into the gate. So you had a lot more power being consumed when you dropped it a line down low. So our gates were typically not gates. I mean, they were NAND and NOR gates. So a AND gate, 3-input AND gate looks like that. A 3-input OR gate looks like that. If I negate the whole mess, so I come up with a NAND, that would be an AND gate followed by an inverter. And another way of doing this is to put a circle at the output of the AND gate. So if this is A, B, C, what is that equal to? Give you some choices here. We'll make it binary since that's what this class is about. Which is the correct answer? You do your ANDing, then you negate the output. Everybody all right with that? And if you had a NOR gate, you would take the OR gate and then the output of it you would invert. So that would be A or B or C, and that whole quantity negated. Sort of makes sense? Okay. The NAND gate and the NOR gate were called universal gates. What do you suppose is meant by that? Really, really big? You can do everything with it. You can implement an AND gate. You can implement a NOT gate. Okay. With a NAND, you can't implement. Well, you can implement an OR. Okay. So let's go through a set of standard gates. So let's say that what I want to, well, you tell me what function does this implement here? So you see, this is in what type of a form? It's a sum of products form. See, our first level of gates are doing a product, doing an and then we OR those guys. Correct? Okay. So what is the F equal to? In fact, let me do this. I'm going to make the B over here, and then again, the NOT is typically unavailable for an input variable, and you'll have to generate it. And so I'll also have to do this, right? I'll have to generate the not A. So give me what that function is. A, B bar, or A bar, C. Everybody okay with that? Okay. Now, watch what I'm going to do here. What have you noticed I've done?
Put squares in.
I've only used what? Only NANDs. Right? Just, I've used 1, 2, 3, 4, 5, 5 2-input NAND gates. Everybody doing okay with that? Yeah?
The A bar right after that, that's a NAND gate also.
Mm-hmm. Okay. Let's take a look at we'll do a truth table for an AND operation. Okay, this is really important. Okay, what are our possible combinations of A and B? And we don't have to do a gray code here. We're doing a truth table. 0, 0, 0, 1, 1, 0, 1, 1. Right? If you want to do a gray code, that's fine. What's A and B?
0.
A and B here. A little bit more enthusiastic. A is a 0, B is a 1. What do we end up with?
0.
0. Thank you. Here?
0.
0. Here? 1. Okay. Now what happens if I negate that whole mess then? 1, 1, 1, 0. Okay. For a NAND gate, this is the way I like to remember it. Any input low, the output goes high. So the only time the output on a NAND gate is low is when you have both the inputs at 1. Yeah.
Can you say that one more time?
Okay. Any input low, the output is high. Doing all right? So while we're on this doing truth tables, let's see if we can figure out what a NOR gate does. There are possibilities of inputs for the 2-input OR gate. Well, you're still copying over there? My chalk is faster than my pizza.
What is the box that's with the NAND gate?
It's where he's putting B in on for both inputs. Like it's like if you could separate it.
Yes.
Both lines are B's.
Both the inputs, it's a 2-input device. Both of them are the same variable. Okay, we'll talk about that. Everybody up with me? Okay, so let's take a look at the NOR gate. Possibilities for A and B: 0, 0, 0, 1, 1, 0, 1, 1. All right, we're doing an OR gate now. 0, 0, OR together gives you 0. 0 or 1, 1 or 0, 1 or 1. Now, negate those, and you end up with 1, 0, 0, 0. So over there, I told you that if any input is low, what's the output do? Goes high. Over here for our NOR gate, what do you notice? Any input high, what's the output do? Goes low. So like I say, for the NOR gate, I like to remember it like that. I mean, you certainly don't want to have to keep going through the truth table on this thing. Okay? AND gate, any input low, output goes high. NOR gate, any input high, output goes high. Everybody with me? All right. So let's go back over here now. As you saw, I've got a NAND gate, but both of its inputs are the same thing. So what happens over here if I put 0, 0 in? I get out 1. If I put a 1, 1 in, I get out. Do you understand that's exactly the same thing as a NOT gate? If you put a 0 into a NOT gate, what do you get out? Put a 0 into a NOT gate, you get out a, put a 1 in, you get out. I just made a NOT gate. Yeah? Okay. What variable do I have? Now be careful. I want to be just on the inside of the circle there. So I'm just ANDing these things. I'll knot it in a minute. So right here, we'll do that one in a minute. Right here, what do I have? A and B bar. Yes? What do I have here? A and B bar, which apply De Morgan's theorem to it becomes what? A bar or B bar, which is B. Everybody okay? All right. Let's continue on here. I should have put that this is B bar here. What do I have out here now? This is a A bar. Wonderful. Okay, so let's go just on the inside of my circle before I do the negation. That's going to be what? A bar and C. What am I going to have out here after I do the negation? A bar, C bar, the whole thing. But that reduces down to A or C bar. Doing okay? All right. So now, what do I have right here?
A plus, or A or C bar.
Well, let's start at the top. A bar or B, correct? I've got this variable ANDed with
A or C bar.
A or C bar, that variable. There we go. Trace that down. This is going to be A bar or B ANDed with A or C bar, but the whole thing barred. Yes?